Hey folks, this is Dan Lattiser for Chem-125, Doane University's online program, and I'm coming to you for Week 3, Module 3, Interactive Advanced Concepts presentation. Today we're going to be going over the reaction of baking soda and your standard household vinegar. Today I have a distilled white vinegar, 5% acidity, as my weak acid, and your standard household baking soda as the weak base, as a sodium bicarb. And yeah, so today we'll be looking at the reaction of the sodium bicarb and the being put into the vinegar, and watching the reaction that happens. I've already written this down as to exactly what kind of goes down. So we'll take a look at that, and then we'll get to the experiment. What you can see here is our in a solid state. Sorry. In a solid state, we have our sodium bicarb, our weak acid, and vinegar, and it's eventually going to be produced into a carbon dioxide gas, H2O in liquid form, and some sodium and acetate in aqueous form, the ions. What you end up ultimately getting is a byproduct in dilute of sodium acetate between that guy and that guy right there. But what we're also looking at is it's a kind of a two-step process, in that when the sodium bicarb and acetate mix together and cause a reaction, what you end up getting is a reaction of carbonic acid then turning to H2O and CO2. So it's not necessarily displayed right here in the step, but there's a displacement that occurs, and then decomposition. This is a decomposition reaction. And then, as I've read, if you take the excess byproduct dilute and you boil it all off, boil all the remaining water and excess of vinegar, you will ultimately come up with sodium acetate in a crystallized solid form, and that's if you boil it all off in a pan. This reaction is going to be extremely similar to that of last week's involving the Alka-Seltzer. The difference with the Alka-Seltzer is that we weren't combining, it wasn't an immediate reaction, in that we were combining the acetate to the sodium bicarb, and because both of those were originally in a solid state, which you can see here, this is a very similar compound in solid state. In this case, our acid is already in a liquid form, and so when our solid of baking soda reacts with the acid immediately, and obviously this is going to be most likely this is going to be in our excess, and this will be our limiting reagent. So having the sodium bicarb placed directly into the liquid state of our acid, the reaction that we would have seen with our original Alka-Seltzer is going to occur a lot quicker, because this took time to dissolve in the water, and as it dissolves in the water, then the molecules are freed and allowed to interact with each other. In this case, the reaction doesn't have that delay in being dissolved, and the molecules are free to interact with each other at a much quicker rate. So I have my distilled white vinegar here. We're gonna just pour it in. There isn't any specific amount that they stated to use. I think that amount right there, maybe about a quarter of the way, is sufficient. We're going to be placing that into this bucket so that it doesn't spill everywhere. And then I have my weak base, the baking soda, and I'm just going to put a little healthy amount there. And that's going to get just kind of crumpled up. And what we're going to do is we're going to drop it in. And you're going to see ultimately that reaction there where we're going to get our carbon dioxide, our H2O, and our aqueous ions of acetate and sodium. The CO2 is obviously going to escape out of the top here, so that'll be part of the loss that we get in our environment. So here we go. So very similar to the Alka-Seltzer experiment, but it looks like my quantities are not up to par with the volcano reaction. So I'm going to add in more solution, or I'm going to add more of our, and we're still getting a reaction going on there. It's a little bit hard to tell up close or on the camera, but there's definitely some gases being created there. And we'll go ahead and we will up the ante with quite a bit more bicarb. And hopefully we can get the the volcano reaction. I'm also not, I don't have the appropriate container for the experiment, and that it doesn't really it doesn't bottleneck, which definitely helps in the physics of the reaction being forced up and out a lot quicker, the tighter bottlenecking container. But here we go, round 2. And there's your volcano reaction. Another thing I was reading was that because of the CO2 because of the CO2 reaction and the gas, that this little concoction is also a helpful little simplified chemical fire extinguisher, in that it displaces the oxygen from the fire, which obviously accelerates combustion. So that that's another little thing. I'm sure there's some videos online how you can produce a little baking soda vinegar chemical fire extinguisher. So we still have some of that burning off. Now if I took this and took this whole solution and boiled it off, I'd be able to get the sodium acetate, which supposedly burns off or ends up forming in a crystalline solid state. And just to kind of make my point that this experiment essentially is the same thing as the Alka-Seltzer, except for it's not citric acid, but it's similar. So it's another weak acid being combined with a weak base. So here's the Alka-Seltzer in the vinegar, which is going to be very similar to the vinegar, or very similar to the Alka-Seltzer water, oil, lava lamp experiment, but it's going to be at a quicker rate because it's not dissolving in water, it's dissolving in the actual acid. That's burning off fairly quick. But definitely not as fast. It's not in that loose. It's not in that loose, powdery, solid state. So anyway, that conducts the video. There you go for your reactions and the chemistry behind it. I hope you guys enjoyed. Have a wonderful weekend, and I will see you guys next week. Thanks for your time.